So a pleasant afternoon, my dear students. Today's afternoon, we are going to discuss about the projectile motion. Okay, so what is projectile motion? Okay, projectile motion is the motion of an object thrown, projected, or launched into the air. Okay, so for example, we have when a cannonball is fired from a cannon. We also have throwing a basketball in the basket, and of course, water escaping a hose. Okay, so those are the real life applications of projectile motion. Now we have two types of projectile motion. First is the horizontally launched projectile. Okay, so horizontally launched projectiles have no upward trajectory or no initial vertical velocity. Okay, so it is sometimes called as the downward motion, while the vertically launched projectiles have no vertical velocity at the top of the trajectory. Okay, meaning if the object reached maximum height, the vertical velocity is equal to zero. A vertically launched projectile is also called as the upward and downward motion. Next are the different formulas under the first condition. Of course, when we say first condition, we are referring to the horizontally launched projectile. Okay, so that horizontally launched projectile have two components: the horizontal component and the vertical component, or the horizontal motion and the vertical motion. Okay, so the formula in the first condition under horizontal motion, considering that acceleration is equal to zero, we have velocity. Okay, so the initial velocity is equal to the final velocity. And the formula in getting those velocities is equal to VI cosine theta. Okay, for the displacement, we have R is equal to VIX times time, or you can also use V1 cosine theta times time. Okay, while for the formula in the first condition under vertical motion, considering that acceleration is equal to 9.8 meters per second squared, velocity is equal to VIY is equal to zero. Okay. Vfy squared is equal to 2 times g, or the acceleration due to gravity, times height. And we also have Vfy is equal to g times time. Okay, for the displacement, okay, the formula in getting the displacement, we have 1/2 gt squared and Vfy squared times Vy1 squared all over 2g. Okay, so how are we going to know, or how are we going to know what formula to be used? Okay, so first is to determine what type of projectile is given in the problem. Second, determine all the given. And then third, look for the formula that can be used using the given data. Okay, so for example, we have this kind of problem. A plane traveling with a horizontal velocity of 100 meters per second is 500 meters above the ground. At some point, the pilot decides to drop some supplies to designated target below. How long is the drop in the air, and how far away from the point where it was launched will it land? Okay, so from the given problem, we have 100 meters per second as your horizontal velocity, that is V1x. Okay, and you also have 500 meters, which is the height. Okay, now we are looking for the how long pertaining to time and the how far pertaining to range. Okay, So the illustration for this example is given. We have the height, which is 500 meters. We have the initial horizontal velocity, which is 100 meters per second. And we are looking for the range and for the time. Okay, so for the formulas that will be used, we have in finding the R, we have R is equal to VIX times time. And in finding the time, we will be, or we are going to use H is equal to 1/2 GT squared. Of course, we cannot calculate for the value of range if we do not have yet the value of time. So let's start getting the time first, and then we can substitute the value of time after getting it through this equation. Okay, so for step 1, okay, compute for the value of time using this equation. H is equal to 1/2 GT squared. Okay, since we have 500 meters as the value of height, and of course, acceleration due to gravity is constant, which is 9.8 meters per second squared. Therefore, we are going to manipulate this formula in order for us to derive with the equation of time. So first is to cross multiply. 2 times h is 2h is equal to gt squared. Now divide both sides by the value of g. Okay, cancel gravity. So we have t squared is equal to 2hg, or we have t is equal to the square root of 2h over g. Okay, after getting or deriving to the equation of time, we can now substitute. We have square root 2 times the value of height, which is 500 meters, divided by the constant value of acceleration due to gravity, which is 9.8 meters per second squared. Okay, so the answer here is 10.10 seconds. Okay, so we have the value of time, it's 10.10 seconds. Now we can solve for the value of range. So for our step 2, we have R is equal to VIX times time. Okay, your VIX is 100 meters per second, and the value of time is 10.10 seconds. Okay, so 100 meters per second times 10.10 seconds is equal to 1010 meters. Okay, so our final answer for time is 10.10 seconds, and for the range is 1010 meters. For the second example, a ball rolls off the edge of a 2 meters high table with an initial velocity of 10 meters per second. How far from the edge of the table will the ball land, and find the ball's velocity just before it strikes the floor? Okay, so in this example, we have a given of 2 meters. Okay. And we also have the initial velocity, which is 10 meters per second. Okay, so VI is equal to 10.0 meters per second. Height is equal to 2 meters. Okay, and for the unknown quantities, we have how far. Okay, again, range, and find the ball's velocity after it strikes the floor. So that is VF. Okay, so let's see the illustration. So VI is equal to 10 meters per second. Okay, VI is equal to 10 meters per second. The height from the edge of the table is 2 meters. And we are looking for the value of the range and the final velocity. But of course, before we compute the value of the final velocity, we have first to calculate the x component and the y component of the velocity. Okay, then after getting the x and y component of the final velocity, we can calculate it through the Pythagorean theorem. So let's start. For the step 1, we have, okay, so I'll present first our formulas. Okay, in getting the range, we have Vix times time. But of course, we cannot calculate for the range without the value of time. Therefore, we need first to calculate the value of time using this formula. H is equal to 1/2 gt squared. And in getting the horizontal component of the final velocity, we have VI cosine theta. And in getting the vertical component of the final velocity, we have G times T. Okay. Step 1, from this equation, we have T is equal to 2H divided by G. And then substitute 2 times height, that is 2 meters, divided by 9.8 meters per second squared. Okay, don't forget to cancel units. Okay, so we have the answer is 0.64 seconds. Okay, since we already have, we are now ready to solve for the value of the displacement, which is R is equal to Vix times time. So the initial velocity is equal to 10 meters per second times 0.64 seconds. Okay, cancel seconds to seconds. So 10 times 0.64 is equal to 6.4 meters. Okay, so this is one of the unknown quantities. And for the step 3, we are now going to find for the x and y component of the final velocity. For the x component, we have v of x is equal to vi cosine theta. Okay, so just substitute here. Vi is 10 meters per second. Cosine 0 because there is no angle given, and as you can see, v2x lies in the x-axis, meaning the angle is always 0. So cosine 0 is 1 times 10 meters per second is 10 meters per second. Okay, for the vfy, okay, we have g times t. So 9.8 meters per second squared times the computed time, which is 0.64 seconds. We cancel seconds to seconds. Okay, so 9.8 times 0.64 is equal to 6.27 meters per second. Okay, now that we already have the v of x and v of y, we can now calculate for the resultant velocity or for the final velocity, which is vf is equal to the square root of vfx squared plus vfy squared. So square root, we have 10 meters per second plus VFY is 6.27 meters per second squared. So the answer here is 11.80 meters per second. Okay, so our final answer, the range is equal to 6.4 meters and the final velocity is equal to 11.80 meters per second. So let's now proceed to the vertically launched projectile or the second condition. We have formulas under horizontal motion. Velocity, we have same with the formula. We have V1x is equal to V of x is equal to VI cosine theta. For the displacement, we have R is equal to VIX times time, or you can also use this formula when angle is given. Okay, you could use this formula when the angle is given. So for the maximum displacement, we have VI squared over G. For the vertical motion, we have velocity. Okay, VIY is equal to VI sine theta. For the final velocity, we have VI sine theta minus GT, or VFY squared is equal to VI sine theta squared minus 2GH. For the displacement, we have VI sine theta times time minus, kindly insert there, minus 1/2 GT squared. We can also use this for the maximum displacement, VI sine theta squared over 2G. And for the time rise or time fall, we have VI sine theta times divided by G. And for the time of flight, we have 2 VI sine theta over G. Okay, so those are our formulas for the second condition. Let's try a problem under this vertically launched projectile. So we have here the football is kicked with a velocity of 15 meters per second at an angle of 33 degrees with the horizontal. Calculate the following. A, maximum height reached by the ball. B, time of flight. And C, horizontal distance traveled. Okay, so our given, we have 15 meters per second as your velocity. And of course, the angle is 33 degrees. And we are looking for the H max or the maximum height for the time of flight and for the horizontal distance. Okay. So this is the illustration of the problem. Formulas to be used. H max is equal to VI sine theta squared over 2G. For the time, we have 2 VI sine theta over G. And for the range, we have VI squared sine theta 2 times sine 2 times theta over G. Okay, so since the velocity is already given, the angle is given, and the acceleration due to gravity is constant, so we can just easily substitute those given to these formulas. So step 1, we have H max is equal to VI sine theta 2 divided by 2G. Okay, so you just need to substitute. For the VI, we have 15 meters per second. Sine your angle 33 squared. 2 times 9.8 meters per second squared. Oh. So the answer here is 3.41 meters. Okay, for the step 2, we have T is equal to 2vi sine theta divided by g. Okay, so 2 times the velocity, 15 meters per second, sine 33. Okay, divided by 9.8 meters per second squared. So the answer here is 1.67 seconds. Okay, so the answer is 1.67 seconds. Okay, for the step 3, okay, we have R is equal to VI squared sine 2 theta over G. So VI, that is 15 meters per second, squared sine 2 times 33 divided by 9.8. Okay, so we have 15 meters per second squared sine 66. Okay, 2 times 33 is 66. So the theta will be 66 divided by 9.8 meters per second squared. Okay. So the answer here is 20.97 meters. Okay, let's just put our calculated quantities in the illustration. So R is 20.97 meters. The height is 3.41 meters, and the time flight is 1.67 seconds. Okay, so that's for the third problem. Next problem, we have a football player kicks off a ball into the air with an initial velocity of 30 meters per second at an angle of 60 degrees relative to the ground. Okay, so what is the position of the football after 1 second? What is the velocity after 1 second? And what is its total time of flight? So in this problem, we have a given of 30 meters per second and 60 degrees angle. And we are looking for the position, okay, after 1 second, therefore positions along the horizontal and along the vertical. So we have R for the horizontal, H for the vertical. Okay, velocity after 1 second, we are going to calculate its final velocity. But of course, before getting its final velocity, we have first to calculate the individual component. Okay, so we have the VFX and the VFY after 1 second. And lastly, we have to calculate its total time. So all in all, we have to calculate 5 unknown quantities. Okay, so we have here the illustration. So we are going to calculate the position, the velocity, and the time of flight of this projectile. So for the step 1, or for the formulas, we have for the Rx, V1 cosine theta times time. For the H, we have V1 sine theta times time minus 1/2 GT squared. For the velocities, VFX x is equal to v1 cosine theta or vi cosine theta. For the vfy, we have vi sine theta minus gt. And for the total time, we have 2 vi sine theta divided by the gravity. So step 1, we have, let's place here along the horizontal. Okay, and along the vertical. Okay, because we have to find the position or the position and the velocity of the ball after 1 second. So we have to indicate its x and y component. Okay. So for the position under x component, we have vi cosine theta times time. Okay, substitute, your vi is 30 meters per second. Cosine, the angle is 60. Times, of course, the time after 1 second. So let's place here 1 second. Okay. So cosine 60 times 30 meters per second is 15 meters per second. Or, okay, so it should be 15 meters, okay? Sorry, it should be 15 meters because we are getting the position, therefore pertaining to the distance. Okay, so that should be 15 meters. And along the vertical, we have h is equal to vi sine theta times time minus 1/2 gt squared. Substitute, we have 30 meters per second sine 60 times 1 minus 1/2 9.8 meters per second squared times 1 second squared. Okay, so the answer here is the answer here is 21.08 meters. Okay, so the position of the ball after 1 second for the horizontal component, it's 15 meters, and for the vertical component, it's 21.08 meters. Okay. Step 2, let's find the velocities under x and y component. Okay, so for the along the horizontal, we have Vfx is equal to Vi cosine theta. Okay, so just substitute, we have 30 meters per second cosine 60. And that is 15 meters per second. Okay. While in the vertical component, we have Vfy is equal to Vi sine theta minus gt. So we have Vi is 30 meters per second sine, and then the angle is 60. Minus 9.8 meters per second squared times 1 second. Okay. So the answer here is 16.18 meters per second. Okay, so the velocity under horizontal component is 15 meters per second, and the velocity after 1 second under vertical component is 16.18 meters per second. But for us to get the final velocity, we are going to use the Pythagorean theorem. Okay, so for the VF after 1 second, that is equal to the square root of V of x squared plus V of y squared. Okay, I'll just continue here, okay? So substitute square root of 15 meters per second squared plus 16.18 meters per second squared. Okay, so our final velocity after 1 second is 22.06 meters per second. Okay, so as you can see, there is already a difference between the initial velocity and the velocity after 1 second. Okay, for the total flight, let's just put our solution here. I'll just draw a box for the total flight since there's no space. Okay, so anyways, we're just going to substitute it. So 2 times velocity, that is 30 meters per second. Take note, do not use the final velocity after 1 second, okay? Because we are looking for the total flight, therefore start with the initial velocity. So 2 times 30 meters per second sine 60 divided by 9.8 meters per second squared. So the answer here is 5.30 seconds. Okay, so again, the positions of the ball after 1 second for the x component, it's 15 meters. For the y component, it's 21.08 meters. Its final velocity after 1 second is 22.06 meters per second. And its total time flight is 5.30 seconds. So that is for the fourth problem. Now, let's proceed to the circular motion. Okay, so what is circular motion? Circular motion is a movement, as you can see in the GIF. It is a movement of an object along the circumference of a circle or rotation along a circular path. Okay, for example, we have a planet revolving around the sun. We also have a stone tied to a string, and of course we have the merry-go-round. Okay, so let's have the formulas involved under the circular motion. We have period is equal to t is equal to 1 over f. Okay, so so t is equal to 1 over f. Okay, next we have the frequency. It's f is equal to 1 over t. For the linear velocity, we have v is equal to 2 pi r times t. For the central acceleration, we have two formulas. It's either AC for centripetal acceleration is equal to v squared over r, or AC is equal to the angular velocity times r. Okay, if the velocity is in unit meter per second, use AC is equal to v squared over r. But if the velocity is in unit rad per second, use this centripetal acceleration formula. I repeat, when the velocity is in meters per second, use the AC is equal to V squared over R. But if the velocity is in rad per second, use this equation. Okay, so I hope that's clear. For the centripetal force, we have Fc is equal to mv squared over r. Okay, so computations of circular motion is relatively far easier from the projectile motion. So example, what is the magnitude of the force that keeps the 75 kilograms pilot in circular motion if he is lying a small plane at 35 meters per second in circular path of radius 120 meters? Okay, so take note of the given. We have 75 kilogram, that is mass. We also have here meters per second, that is velocity, 35 meters per second, and radius, okay, r is equal to 120 meters. And we are looking for the force or the centripetal force. We have here the formula of the centripetal force. Fc is equal to mv squared over r. So okay, the mass is 75 kilograms. The velocity is 35 meters per second. Divided by the given radius, which is 120 meters. So the answer here is, okay. Allow me to have my calculator. So we have 75 times 35 squared over 120, that is 765.625, or we have 765.63. Okay, and take note that the unit of force is Newton. Okay, so unit of force is Newton. Or you can just write your answer as 766. Okay, it's also considered. Okay. Now, let's proceed to some other problems. Problems involving the vertically launched projectile, involving the horizontally launched projectile, and circular motion. So first, we have a soldier fired his gun horizontally from the top of an 80 meters high building with a velocity of 400 meters per second. Neglecting air friction, how far from the base of the building would the bullet land? As I've said a while back, always determine first the given. So we have height is equal to 80 meters. And the velocity is 400 velocity is 400 meters per second. Okay, so we are looking for the how far, for the range, right? Okay, so it's just easy because our first two problems a while back are also finding for the value of range. Therefore, we are now familiar that in order for us to get the value of range, we should find first the value of time using this equation. We have h is equal to 1/2 gt squared. Of course, manipulating the formula, we got t is equal to the square root of 2h times g, right? Substitute square root of 2 times height, which is 80 meters, divided by the acceleration due to gravity, which is 9.8 meters per second squared. Okay, so my answer here is 4.04 seconds. Okay, so it's 4.04 seconds. Now that we already have time, we can now calculate for the value of the displacement. So it's R is equal to V, okay, it's VIX times time. Okay, so VIX is 400 meters per second times the computed time. It's 4.04 seconds. Okay. Okay, so the value of range is we have 400 times 4.04. Okay, it's 1,616 meters. Okay, so how far from the base of the building would the bullet land? It's 1,616 meters. So that's for the first example. For the second example, a baseball player hits a ball with an initial velocity of 32 meters per second at an angle of 30 degrees. If air friction was neglected, how far from the baseball player would the ball land from the ground? I repeat, a baseball player hits the ball with an initial velocity of 32 meters per second at an angle of 30 degrees. If air friction was neglected, how far from the baseball player would the ball land from the ground? Okay, so given we have initial velocity VI is equal to 32 meters per second, and the angle is 30 degrees. So we are looking for the how far from the baseball player would the ball land from the ground. Okay, so first is to so I'll check the formula. Okay. Okay. So step 1 is to find the initial vertical velocity of the component velocity, okay, or of the quantity velocity. Okay, since we are given initial velocity and we don't know its x and y component, we have first to compute the x component of that velocity. So our formula is Vx is equal to V cosine theta or V1 cosine theta. Okay, so our V1 is 32 meters per second cosine 30. Okay, so we have 27.71 meters per second. So that is the velocity under x component. For the second step, we will be finding the value of time since time is not included in the given. So to find time, we have T is equal to 2 pi sine theta divided by g. Since velocity 1 is given, angle is given, so we can just substitute 2 times 32 meters per second sine angle divided by 9.8 meters per second squared. The answer here is 3.27 seconds. And in finding the range, we have step 3. It's R is equal to V VIX or VX times time. Okay, so we have Vx, the computed the computed horizontal velocity, which is 27.71 meters per second, times the computed time, 3.27 seconds. Okay, so that is 90.61 meters. I repeat, the reason why we have to calculate for the value of Vx is because we only have the initial velocity, and the problem is pertaining to the horizontal component. That is why we have to indicate the horizontal velocity and not the initial velocity. Okay, so for the step 1, find for the horizontal velocity, which is through V1 cosine theta. Okay, and it gives us 27.71 meters per second. Now, after finding the velocity, you can solve for the value of time using this equation. Okay, so using this equation, we cannot use the formula of time that we had in our previous examples because we do not have height in the problem. Okay, so as I said a while back, you should look for or determine the given and then look for the formula that is suitable, okay, or that is suited for the given data. So we have 2 vi sine theta divided by the acceleration due to gravity, and we have the total time is 3.27 seconds. And of course, for the step 3, just have this formula Vx times time, which is your Vx is 27.71 meters per second and your time is 3.27 seconds. And the answer is 90.61. Okay. Third example, Alma sits 1.5 meters from the center of the merry-go-round. If she undergoes a 1.25 meters per second squared centripetal acceleration, what is her linear velocity? Okay, so our formula under linear velocity is, or of course, we have to identify first our given. We have 1.5 from the center, that is the radius. We also have the centripetal acceleration, which is in meter per second squared. And we are looking for the linear velocity. Okay. So in the formulas presented a while back, we have AC is equal to V squared over R, right? So we can use this formula in order for us to get the value of the linear velocity. So you just cross multiply. We have ACR is equal to V squared. Okay, or it's V is equal to the square root of ACR. And then you can just substitute square root of AC. It's 1.25 meters per second squared times the radius, which is 1.5 meters. Okay, so the answer here is 1.37 meters or 1.37 meter per second. Okay, so that's the linear velocity. And for the last example, what is the magnitude of the centripetal acceleration of a piece of clay 0.5 meters from the center of a potter's wheel if the wheel rotates at 20.5 rad per second? Okay, so our radius here is the 0.25 meters, since it's already indicated that it's from the center of a potter's wheel, and then it rotates at 20.5 rad per second. Okay, therefore it has an angular velocity, or this one, angular velocity. This is the symbol of angular velocity, huh? So our angular velocity is 20.5 rad per second. And we are looking for the centripetal acceleration. Okay, so our formula for centripetal acceleration given the angular velocity is AC is equal to W squared over R. So just substitute 20.5 rad per second squared times 0.25 meters. Okay, so my answer is 105.06 meters per second squared. Okay, so that ends our problem solving. But before I end this discussion, always remember that in this life, there are many factors that challenge us through our journey. But as we fly with our dreams, there will be a time that we will be able to attain the highest peak of our life. As we go on and look back, we can see that our range is far from where we started. You just have to keep going and believe in His ways. As being said in Proverbs 3, chapters 5 to 6, trust in the Lord with all your heart and lean not to your own understanding. In all your ways, acknowledge Him and He shall direct your paths. Okay? So that's all, my dear students. I hope that you learned this afternoon. Thank you so much and keep safe.